Happy return. So introduction, I guess, continued with regards to confidence intervals, except this is for proportion of a population. So it relates back to binomial distributions. So if you remember, in binomial distributions, we can actually approximate them by normal distributions. So we would have, for instance, our mean, okay, which would be, approximated by n times p, so that's just the expected value that we would get, and then our standard deviation, okay, was approximated by n times p 1 minus p. So for that approximations, if you like, I'll put up a link up above there. You can go back to that. And now we can use those approximations to actually create these confidence intervals like we did for the normal distribution. Okay, so let's take a look and see. Now we will actually kind of normalize them because we don't want them over a specific n per se. All right. We will want them just with regards to a proportion. So, p was with regards to some kind of a success, and then 1 minus p is just a failure. So we want to be able to use that. Now, if you recall, okay, so from the confidence intervals video, okay, so with regards to the introduction, so again, I'll put up that up above there. It's definitely needed, okay, in here in order for you to understand, okay, these confidence intervals for proportions. So what we were trying to do there is we were trying to find a confidence interval where we would have, okay, some approximation of our overall mean of the population, and we wanted to find out where that mean would actually lie based on just having some kind of a sample with, okay, so that sample being of n data points, and then creating an interval, so from the left to the right, okay, and then that interval would say that this is where our, possibly with some confidence level, our actual mean would lie, okay? So within here, so our confidence level is 1 minus this alpha. So an alpha was simply the probability, okay, of error, okay, threshold that we are to tolerate. And on a graph, what this was actually referring to was the following. So we would have, so here's our normal distribution. So we would have something like this. So we're saying that, okay, well, we're going to have some kind of a sample. Now, this particular sample is going to have some confidence interval, okay, so it's going to fall somewhere in between. So let's say, possibly, okay, maybe that interval is going to lie somewhere between here, okay, and then around here, maybe it's at 95% confidence, okay, threshold that we want to have, so our confidence level. And what we're saying is, so somewhere around this area, so from here to here, so if I do this, okay, we want to see our actual true mean to lie. So somewhere along within here. So that's what we were doing. And then our error, okay, term was basically, okay, so to the left of this, all right, and then to the left of this, okay, so, this particular point, so this is our threshold over 2, so this is on the negative side, and this is our threshold over 2 on the positive side, okay, with regards to the, z-scores that we would have. So now, could we possibly extend this to the idea where we're not just directly working with a normal distribution and we have some kind of a sample, but could we extend it, okay, with regards to the binomial distribution, and in particular, could we extend it, okay, to this proportion? So, where does this come about? Well, if you're going to be trying to find out some kind of an opinion within a population, for instance, so what do people think? So how many people support a particular opinion, or how many people are opposed to a particular opinion? Then basically you're just grabbing a proportion of the population, and you might say, okay, well, we have 70% of the people are actually supporting a particular opinion. So this actually becomes a binomial kind of a distribution in a sense, where you would have, a probability P, okay, so with some proportion of, let's say, support for an opinion, or, maybe opposing. And then, 1 minus P, which is against the opinion, or again, vice versa, or maybe supporting. So those are the two instances that would happen, okay, within here. So how does that change? Well, it changes for us because now we no longer have, an actual mean, okay, of the sample, because we're interested in the actual proportion. And our ultimate goal is to try to find what is the true proportion with regards to the entire population, and not just with regards to the sample that maybe we took. So this brings about new confidence levels as well for us. So what we would have is, okay, so if I think about this being my confidence level, okay, so from left to right, so how would this change? So I'm going to just kind of drop it down here below. So this would be changing in the following way. Okay, well, we are no longer talking about being interested in the mean of the population with regards to some normal distribution, but we are interested in trying to find out what the actual probability P, okay, what that proportion is that maybe they're supporting some opinion. And that, of course, now changes for us, because if we do take a sample, so, if we start sampling out, and then we're sampling, and then we have n, okay, data points within, and then within that data points, we want to see, okay, so how many people are supporting our opinion or are opposing it, then this changes, okay, this interval. So on the left-hand side, I'm not going to be talking about x anymore. Really, okay, what I am trying to approximate is, okay, this p, okay, proportion with regards to the whole population. But I'm only capable of finding this out, okay, for this particular sample that I took. So, maybe I found that the proportion, so I'll put P little bar, it's kind of like the mean, okay, of that proportion that I have, or of that particular sample. And this would be on the left and on the right as well. Okay, so now, okay, I am trying to approximate my overall proportion, so my probability P, okay, by the actual sample with n data points. Now, because I can approximate binomial distributions, okay, with normal distributions, so I can still hold my z-scores, all right? Now, my threshold doesn't change, so this threshold over 2, again, I can have some confidence level, so maybe, a 95% confidence level, or maybe a 90% confidence level, as we talked about in that video, okay, or maybe 99, which are the most common ones. So in this case, I can pick off my threshold here, okay, and on the left to see what it is. So this actually stays the same. Okay, so this changes because we're going to try to find what the proportion is within our actual sample. Okay, so that is no longer the mean. So that is that. The z is the same. And now, okay, it also brings about, what the heck is this? Sigma over the square root of n. Okay, so divided by the square root of n. Well, the square root of n, keep in mind, okay, so the sigma over that, it means that we were trying to work with repeated sampling, right? So that's where it came from. From repeated sampling, we noticed that if you take the same number, okay, of data points within a sample, and you keep sampling that over and over, we knew that that was normally distributed. And then the actual standard deviation was sigma of the original population divided by the square root of n, how big your data, okay, or your sample was. But we don't have a sigma here anymore because we're talking about proportion, so success and failure. And then you might recall, okay, so again, so we had it right here, that our actual sigma, so our approximated sigma right here, so let me copy and bring it down, that's what it was, right? So you might think, oh, okay, well, that's what I'm going to be using, okay, and this is going to be my sigma that I have right here. Not really, because we will not have this n in here. Because when we were approximating the binomial distribution, we had a fixed, okay, number of points that we had. Because remember, binomial distributions actually was with respect to some particular fixed amount. Now we have a huge population and we're trying to gauge the opinion of the entire population. And within that entire population, we may not even know how many people, that there are, but we only want to take a sample of that entire thing. So it's not the same N. And we're really just interested in, this P right here. And this P is just a proportion, right? So it doesn't matter how many people you're going to be sampling. We want the proportion, of the entire population, of people, how many are actually supporting our opinion or maybe opposing that opinion. So this N actually drops off because we're not interested with respect to the N in here. So this now becomes, just square root of P multiplied by 1 minus P right here. Okay? Now, the division by the square root of N, this N that we have in here, that will stay because, again, we are interested in the actual averages, right, between all the samples that we would have taken that had N data points that we sampled. So this is really, really hairy, in terms of trying to understand it. But I'm going to try to show you, how to apply it and how you can calculate these intervals. So calculation-wise is one thing. You probably can do that. You can memorize it. Getting the intuition behind what you're doing, that's a little bit harder and more challenging. And you have to really think about this. So let me just rewrite this entire thing, what this interval, confidence interval now will look like, So let me do that. All right, so here it is, So that is actually our confidence interval, And we're trying to approximate the probability P, so the proportion of the population that maybe are supporting a particular opinion or opposing it, whatever it is that we're trying to find. So notice that what I used, within here, the big changes, this isn't really a big deal, right? Because you would think about this as just the mean, all right, of that N data points that we had. So that's the same thing as we had in the normal distribution. That was just our X bar. Now our Z score again, so this is not any different. So this is still the same. So the key difference that you see here is this. All right, so our sigma now becomes the square root of P, multiplied by 1 minus P. But notice that I put P bar because we don't know the P. Right? That's what we're trying to approximate. If we already knew the P, then there is no confidence levels at all, or confidence intervals that we have. So we're actually going to be using, within here, the calculation for that P from the sample that we took. And then we're going to be dividing by the square root of N, just like we did for that normal distribution on the confidence intervals. So, just as a short little example here, so you can imagine, let's say, that you took, so N, maybe was 1,000 people, right? So that you are taking a survey of randomly choosing 1,000 people. So that's fine, right? So nothing to think about there. And now what you found is, let's say that, you're trying to find out, if they support an opinion or if they're opposing an opinion, whatever it might be. So now maybe that P, now this is going to be the P of your sample. Maybe it was, I don't know, let's say 61%. All right, so you found that 61% of the people are supporting it, which means, that of course 39%, so 1 minus the P bar, so that's 39%, maybe we're opposing it. That is from this sample, so that's that. And now from this, you wanted to see that, so based on this, I want to see, how closely can I figure out, this P with some confidence, meaning of the entire population, right? So how would I calculate that through? Well, I would substitute everything within here. Now, what confidence level do you want to have? So let's say my confidence level, so 1 minus the alpha, okay, so my confidence level maybe, let's say it's 95, okay, or it's 95%. So it's one of the common ones that we have. Now, from those common ones, so the 95%, well, we know what that was with respect to these z-scores, right? So what this really would mean is that my alpha, so within here, okay, is just 5%, okay, and we're supposed to divide this by 2, so alpha divided by 2 is 2.5. So that was on the tail end here, right? So in our distribution, okay, so on the tail end, 2.5% on the left and 2.5% on the right. And now to calculate this whole thing through, okay, so what would we have? Okay, well, so let me remove all of this in here. Okay, so let me delete that. I wanted to find out, okay, what this is. So I'm going to just calculate this right here. Okay, so that's what I'm going to try to calculate. And then I can find out the rest. So, well, my z-score, okay, for 95% confidence level, okay, so we've done that in the previous videos, okay, so I'm not going to repeat that again, but that z-score, okay, was, okay, 1.96, okay, so approximately. Now you're going to be multiplying it, so now this is going to be square root of, so you take this, so you take it, okay, not as a percent, but as a decimal, 1 minus p, so this is going to be 0.39. And then you're going to divide by your square root of, okay, how big your sample size was. So now with this, okay, so if I calculate this through, 1.96 multiplied by, and this is going to be square root of, so 0.61 times 0.39, okay, so that's all of that. Now this whole thing is supposed to be divided by the square root of 1000, and now hit equals, and you notice that this is going to be 0.0 approximately 3. Now what does that mean, right? So this interval now that we have, well, what this means is that we have my interval, so my p possibly lies within here. Now my p bar, so that's 61%, so this is 61%, plus, I just calculated, well, this is about 3%, so plus 3, and then here, this would have been 61% minus the 3%. So what this is saying, okay, so now that you see this right here, this is saying that with a 95% confidence level, okay, my confidence intervals are basically, so if I do that, it will be between 58% and 64% of the entire population, okay, maybe are supporting this particular opinion that I took, right? So this is a very much a binary distribution. It's not necessarily a normal distribution, but we can do these confidence levels within here. So that will now help you, right, to try to gauge. Now, this 3% is basically like saying that you have some kind of a margin of error, plus minus 3%, with a 95% confidence level, okay? So that's one example. Now, I've made this up on the fly so that you can see how to create and calculate these confidence levels. Now, what if we actually had a word problem? So here's a word problem, okay, that we can do this, again, to try to see how this works. So let's say in a random survey of 2017 people from the population, it has been shown that 70% of the people agree in supporting amateur athletic sports via government funding. Okay, so this is basically, okay, what we are trying to see, proportionally what happens. So what I have n, so now n is a little bit odd because it's 2017. Now my p bar, so the proportion of the sample that are supporting, okay, in this case the amateur athletic funding, okay, is 70%. So this is going to be 0.7. 1 minus the p bar is going to be 0.3. Okay, so that's what I have so far. And it says, based on this survey, the article, okay, so maybe somebody's writing an article, wants to claim with a 95% confidence level. Okay, so we want to have, okay, a 95% confidence level, okay, like this. So that means our threshold, so the probability of error is 5%, okay? That the results properly reflect the entire population. All right, so let's take a look. What is the confidence interval? And then what is the margin of error based on this study? Okay, so let's see how we would calculate this. So what do we need to do? Well, so if I take this, so if I take this entire thing, so let me copy it. Okay, I'm going to bring it down. So first we're going to try to calculate our confidence level in here. So let me erase some of these things, and then let's substitute all of this in. So this is going to be 0.7 minus. Now the z-score, okay, related to, okay, the threshold of 5%. So this is alpha divided by 2. So that is equal to 1.96. All right. This again comes out through, okay, going in, okay, and doing either the tables of z-scores, all right, okay, or finding it on decimals, as I did in the original video, okay, so you can certainly do that, okay, or you can use your graphing calculators. However, okay, so as I've mentioned, okay, so these confidence levels, so typically 90% confidence level, 95% confidence level, and 99% confidence level are typically so standard that people just have a short little table, okay? And I actually do have a little table for myself. I always kind of write it down on the side. I did it in the previous video, but for you, just in case maybe you want to jot it down. So 90% confidence level, which means a threshold, so an alpha of 10%. Okay, so that's the error. So that gives me a z-score, okay, of 1.645. Okay, so that would be for this right here. Okay, if I have a 95% confidence level, okay, so that is 1.960, okay, approximately. And then if I want even more confidence, so 99%, okay, so that's obviously going to be a much bigger number. So that's 2.576. So typically these, once you start working on this, are going to be the most common ones that you use. And if you want, okay, to find other confidence levels, 80%, 70%, okay, or maybe 99.5% or something like that, then you would have to go back, either use a graphing calculator or use decimals. Please go back to that video, okay, on the normal distribution, okay, for the confidence level, the introduction that I did, okay, I linked it in the beginning, if you want to see how to do that, for example, on decimals. So coming back to this example, so now that I know what that z-score is, so this is just a matter of plugging things in. So this is going to be 0.7, this is 0.3, okay, divided by, this is 2017, all right? So this is my P, okay? And then I'll do exactly the same thing on the right-hand side. So let's see what that is. So I'm going to just, work this out. 1.96 multiplied by square root of 0.7 multiplied by 0.3, and now I want this whole thing divided by the square root of 2017, and that equals 0.0, well, basically 2. So what does this say? This is 0.7 minus 0.02, all right, P, and then this is going to be 0.7 plus 0.02. So my margin, so my confidence interval is, okay, so basically it's from anywhere from 68%, okay, all the way to 72%, right? So that's my confidence interval that I have. My margin of error, okay, so it looks like, so that's this right here, is plus minus 2%. That's what I would actually have within here. Now, this is on a confidence level of 95%. Okay, if you change the confidence level, these are going to be different. All right, so that was kind of another introduction, okay, now related back to calculating confidence intervals with regards to these proportion of a population questions, which relate back to binomial distributions. Okay, thanks for watching, and we might see you hopefully in a future video. Bye, everybody.